Thank you very much for joining us this afternoon for this NRICH live event. My name is Liz and I'm joined this afternoon by Charlie, Claire and Ems. We're all members of the NRICH team based in Cambridge. We're delighted to have so many of you with us this afternoon. We'd just like to mention that we're recording already, so please do keep your microphones muted and your cameras off throughout the event. We're really grateful to Trinity College here in Cambridge who provided funding for this event, which means that you can participate free of charge. The recording of this afternoon's event will be available on the NRICH site later in the week, and we'll give you a link to the page where you can find it at the end of the event. Throughout the webinar this afternoon, we're going to be using the chat facility for you to comment, for you to participate in some mathematics that we'll work on together. So do please check that you can access that should you wish. You may also like to change the way your name is displayed if you want to. So please use the rename function to do that. Just finally, the last kind of admin-y bit before we get started is that in participating, you have agreed to abide by our code of conduct. So please be respectful and then we can all enjoy the event together. If you have any concerns, do send Charlie, Ems, Claire or me a message via the chat. Okay.
Can we just ask for everyone to have their microphones off, because apparently there's some echoes happening at the moment.
Thank you very much, Claire, for chipping in. Yeah, please do make sure your microphone is muted. You'll usually find the toolbar at the bottom of your screen or on your phone if you're using that. Thank you. Please do keep your microphones muted throughout. Thanks, Claire. So this afternoon, we're hoping to give you a chance to find out a bit more about the latest primary problems that we've got on NRICH. We're going to try a few together and then we'll consider the mathematical thinking that you may like to prompt in your own classrooms, or perhaps not necessarily in your classrooms, unfortunately, at the moment, but at least encourage via your homeschooling. At this point, I'm going to stop sharing my PowerPoint and I'm going to instead share the NRICH website. Let me get up the correct browser. Here we go. So I am hoping that you are now able to see the NRICH homepage. This is nrich.maths.org. And because this afternoon we're going to focus on what's available for you as primary teachers, so roughly speaking, ages 5 to 11 children, we're going to go to the primary teacher homepage to start off this afternoon. And you can do that in a number of ways. You may follow the link that is in the left-hand green box, or you could take the link in the top here. I guess the advantage of taking the link at the top is that this menu bar is always visible, whatever page you're on the NRICH site. So let's follow to go to the primary teacher homepage. In the purple box on the left, there are some links to take you to some curriculum support, but we'll come back to those probably later on. For the purpose of this afternoon, we're going to focus on this current feature. So in the blue box here, I'm going to click. By the way, in case you're not so familiar with our lingo, if you like, a feature is just a collection of tasks. It might also include one or more articles all around.
You're muted, I can't hear you.
Liz, I accidentally muted you because I was trying to admit somebody and somebody else admitted them. And my button moved, sorry.
Don't worry, Claire. It turns out Claire accidentally muted me. It's not a problem. Right. It's not a problem at all. I shall just recap slightly. Let's go back to, here is the current feature. Hopefully, hopefully I wasn't silent for too long. It might be a blessing already. So a feature, for those of you who don't know, is just a collection of tasks and possibly an article or more than one article all around a particular mathematical theme. Now, at this point, I'd like to invite Charlie into the conversation a bit more. Charlie, are you there?
I am, yes.
Brilliant. So Charlie and I are going to have a little chat about the overarching ideas in this feature, and then we're going to share with you a few tasks and work on some of them together to give you a better idea of how you could use it with your learners. Charlie, do you have any questions to kick off? Have I missed something out that you think I should explore?
Okay, so I suppose you've called the feature to balance or not to balance. So do you want to tell us a little bit about the key mathematical ideas that you are hoping are going to arise and be discussed by children and teachers when they tackle the problems in this feature?
Yeah, of course. Thanks, Charlie. So as the text at the top says, the main mathematical idea behind this feature is the concept of equivalence. What do we mean by equal in mathematics? What we've tried to do is to build on the practical experiences that children might already have. So hence the seesaw image that you've got there. So that's where we begin with the seesaw. And then we're using that environment in which to talk about balance and link into equality, and also the problems that we've included for slightly older children then lead into considering ways that we might represent equivalence mathematically, so how we might record equivalence.
So presumably this is all good preparation for children at secondary school then, working on equations and then being introduced to the algebraic representations of what they're going to be doing at primary.
Spot on, Charlie. Yeah, absolutely. So what we're doing here is we're already introducing children to ways of thinking algebraically, even if we're not introducing any formal notation. Yeah. So should we have a little go at one of the tasks? Should we have a quick look? So
well,
I thought
shenanigans sounds interesting.
I'm glad you like that, Charlie. Yeah, here's seesaw shenanigans. Let's take a look. So I'm clicking on there. And hopefully you can see, I'm going to scroll down a little bit because I'm going to share with you this interactivity. We've got a group of animals in the woods, a couple of owls, a couple of hedgehogs, 2 robins and 2 mice. Hopefully you can see that. And they've made a seesaw. So we can move the animals around, we can pop them onto the seesaw. Should we have a little go, Charlie? Okay. What do you reckon?
Yeah, hedgehog would be fine.
Okay, so as I move the hedgehog onto the screen, can you see the way the seesaw changes colour slightly? So that all that means is once it changes colour, it means the hedgehog is in the right place to let go of it, in inverted commas. So there we go. What would you like to try, Charlie? Do you think we're going to be able to make the seesaw balance?
I presume the intention is to have 2 hedgehogs of the same weight, so I'd be curious just to check that the other one can be put on the right hand side and the seesaw will go back to being in equilibrium.
I like your thinking, Charlie. So there we go, the seesaw's changed colour. There we go. The seesaw on either side. Yeah, you're right. We're presuming that our hedgehogs are all the same weight. So
and can you put more than one on one end of the seesaw?
You can. What would you like to try?
I don't know. I'm curious to know whether, for example, might 2 mice weigh the same as a robin, or 2 robins weigh the same as an owl, or
okay. So what did you say? Do 2 mice weigh the same as a robin? Let's try. So if we pop a robin on that side. And 2 mice here. What do you think? I'll let go. So you're right. A robin is the same weight as 2 mice.
And if we put the robin next to the mice, I'm wondering whether they might be the same as the owl.
Okay, so you'd like me to put the robin on the same side as the mice. Okay, let's pop this over here. Okay, and we'll try the owl, you're saying?
Yes.
Okay, so owl on the other side. Ooh.
Okay, so I could imagine that these aren't the only ones that balance. So I'm assuming that the problem asks students to use the information that they gather along the way to find more and more pairs or combinations that will balance.
Exactly that, Charlie. So the idea now is well, actually, why don't you have a little go on your phone, whatever device you're using. If you go to the NRICH site, if you're not already on it, so it's nrich.maths.org, you can see hopefully the URL of this particular task. It's nrich.maths.org/14796. Do have a little play. Can you find any other ways to make the seesaw balance? Please do post your discoveries in the chat. We'll give you just a minute or two to have a little play, and then we'll come back together after that. Okay. Thank you so much for your participation on the chat. It's great to see you experimenting with the interactivity. Well, if not actually seeing you experimenting, seeing the results of your experiments, I should say, perhaps. Just to pick up on one thing that I noticed being discussed in a more general way, the idea about distance from the fulcrum, you're right. In this particular seesaw, the way we've set it up is that it's a slightly artificial situation in the sense that we can only place animals right on the same spot effectively. So you're not able to experiment with distance from the fulcrum. I can see that you've come up with all sorts of other ways to make our seesaw balance. Just to pick up a few, we've got that a hedgehog is a mouse and a robin, I noticed. An owl and a mouse is equal to a robin and a hedgehog, same weight as a robin as a hedgehog. An owl is the same weight as 2 robins, somebody else has said, and an owl is the same weight as a hedgehog and a mouse together. And I'm sure there are others that I have not picked up on. Charlie, is there anything you'd like to pick up from the chat that I haven't mentioned?
No, I don't think so. But I imagine that one conversation that could happen with students is whether there were some combinations of balance that we could have deduced from others, whether one can see perhaps one combination that works in another one and from that deduce something.
Right.
So I could imagine in a classroom having these things written on a board and then trying to make links between one and the other.
Absolutely, great idea. And I think
that in a way is a secondary level when students work on simultaneous equations where they rearrange and they express things differently, and then they combine things together. So I suspect some of the combinations are combinations of others that have been produced. And what I like about this is just how playful it encourages students to be. And there's no anxiety about getting things wrong. You're encouraged to play, which seems to be in the spirit of an NRICH task.
Absolutely, thanks, Charlie. I like the way that you mentioned almost in passing, Charlie, that you might record things on the board somehow. The whole idea of recording in this context is a really interesting one, isn't it? And I noticed that some of you on the chat found ways to record your solutions other than using full words. And I think it would be really interesting to see the ways that children themselves came up with to record what's going on here. Thank you, Charlie. Thank you all for your participation there. Just to flag up, if I scroll just a bit to the top again of this page, on the left-hand side here, I just wanted to draw your attention to the fact that there are teachers' resources to all our NRICH tasks, if you weren't already aware. If I just click, just to give you a bit of a flavour, we always include particular headings in our teachers' resources. So we always start off by explaining why you might want to have a go at this task, to give you a bit of background about the mathematics. So there we've obviously laid out the fact that you're playing around with the ideas associated with equivalence, but also this idea of developing young children's language is an important one in this context. Then we might suggest some ways you could actually introduce the task in the classroom. This task was inspired actually by a picture book, which you may well know, called Balancing Act. And so, you could start reading this with the children, and it's as the context in the problem. It's about a group of animals who make a seesaw, and then they find ways of keeping the seesaw balanced when different animals come on and off. You'll always find some key questions to ask of children to encourage their mathematical thinking, and some support and extension ideas. So if you didn't know about the teachers' resources on NRICH, do look out for them, and we're always keen to have your feedback. You will have lots of ideas yourself about how to introduce a task, but this may give you a starting point. If I go back to the problem itself, there was one other thing that I'd like to share with you, which you may find useful. At the top right-hand corner of many of our interactivities, many of the newer ones on NRICH, you'll see this purple cog. If you click on that, it always takes you to a settings menu, and sometimes there aren't settings for you to alter. And in this case, there's only one, but you may be interested to know that we can turn on a symbol. Now, I'm not expecting you to guess necessarily what that means at the moment, but if I click for that setting to take place in the current window, hopefully we'll see a slight difference. So you can see now that you've got an equal sign in the middle of the seesaw. I wonder, Charlie, then if you could predict, if I pop a hedgehog on this side, and I say, could you predict? I didn't give you a chance to predict. I forgot that the minute I let go of the little hedgehog, he sits down.
Oh, you get an inequality sign. You get a greater than sign. So I think if we put an owl on the right, that will then become a less than sign rather than a greater than sign.
Let's check it out. Absolutely. Yeah. So now you may, the default in the interactivity is for a symbol not to be present. But I just thought I'd let you know that there is that option there, should you wish to introduce that to children.
Perhaps we should just explain, Liz, that part of the reason we're having this conversation is that I don't know these problems. I wasn't responsible for creating these problems. And we're going to have a similar conversation tomorrow where we're going to talk to secondary teachers, where you or Claire will be asking questions. And otherwise it might seem a bit strange that I'm pretending, but actually I wasn't involved in the creation of these problems. I'm genuinely curious and interested.
You're right. I should have explained that better at the start, Charlie. Yes, good point. Good point. So there we go. Charlie, have you got any other questions related to that particular task? That's seesaw shenanigans?
No, except that you pointed out that on the left-hand side, there's a link to teachers' resources. There's also a link to submit a solution. And that's because these are live this is one of the live problems, which means that we're inviting students to send in solutions. And then just before half term, that facility will stop. We will look at the solutions the week before half term or the fortnight before half term, and then publish some of the solutions we've received. So teachers joining us today may want to encourage some of their students to send in solutions. And there is a deadline, I don't know, around the 10th of February. I can look it up.
Monday the 1st of February.
1st of February. Oh, right. Okay. Much sooner than I anticipated.
So it's just under 2 weeks' time, the deadline. Yes. As Charlie said, we'd love to hear from you and the children in your class. If you as the teacher would like to write a summary of what they've done, that's absolutely fine. It can be that, or it can be individual children or pairs of children responding. We really don't mind. I guess the key point is that we're looking for solutions that are well explained and offer an insight into the children's reasoning rather than just a one-line answer. Okay, thanks, Charlie. Shall we go back to the main feature and have a look at a different task? Okay, so I'm going to click on the primary teacher button at the top again and take this same route to the feature. So here we are, back again. I'm going to scroll down a little bit. I guess what we didn't say, Charlie, which could be useful, is that seesaw shenanigans problem, we roughly suggest that might be a great task to have a look at with 3 to 7-year-olds. The stars that you can see, we give all our resources 1 star, 2 stars or 3 stars. And as a rough guide, the way that we like to think about it is a 1-star problem would be suitable for a sort of a mixed attainment class. So most children in a class could have a really good go at a 1-star problem. As opposed to, I guess, a 3-star problem might be more suitable for children who perhaps have more experience of problem solving and would like a bit of a challenge. So it's not a 3-star problem is not going to take them out of the curriculum area for that age group, but it will give them a bit more of a sort of a mathematical workout, if you like. So next task, why don't we have a little look at this number balance task, shall we, Charlie? I'm going to click on here. So this is for, you know, a similar age group, but perhaps would reach up to slightly older children as well. We've got another interactivity, slightly different this time. I hope everybody can see that. So this time, my interactivity involves a balance again. I've got some weights at the bottom of the screen. I'm just going to drag one of these weights. Let's put it, why don't we put it on the hook with the 10? You can see what's happened there.
So you get a greater sign in the middle again.
Absolutely. So this time the symbol is on the default version of the interactivity, but you could take it off using the settings menu. What about, I think I might put, why don't I put a weight on the 2? What are you expecting might happen, Charlie?
Not much.
Good answer. Why?
Well, the 10 is heavier than the 2, or greater than the 2. But if you put a weight on the 2 and then another weight on the 8.
Okay. So you're right, not a great deal happened there. It tipped a little bit. And on the 8, you suggest. Why the 8?
Because then the 2 and the 8 add up to 10.
Okay. Oh.
So again, I'm assuming it doesn't make any difference how far away from the fulcrum it is. We're just thinking about which combinations.
Absolutely, absolutely.
Can you put 2 weights on the same number?
Good question, Charlie. Yes, you can. What would you like to try?
On the right-hand side, can you move the 2 weights that you've got there from the 2 to the 5 and from the 8 to the 5?
Yes, you can. And you get the slight difference in display so that you get the number changing on the actual hook to indicate that there are 2 weights there. Yeah. I wonder what, so if we had, let's imagine, if I take that weight off, if I put it this time, if I put a weight on the 7, could you suggest a way of making it balance this time, Charlie?
Okay, well, I think I've got 2 choices. I either put a weight on the 3 or, oh, no, I've got 3 choices. I either use 1 weight and I put it on the 3, or I use 2 weights, 1 on the 1 and 1 on the 2, or I use 3 weights and I put them all on the 1s.
Ooh, whoa, nice. So say that again, Charlie. So you're suggesting I could put 1 weight on the 3 and okay, yeah. We're anticipating a balance. But alternatively, you said, Charlie? I
could put that one on the 2.
Yeah.
And 1 on the 1.
Okay. Nice. So that's also balanced.
Or you could move the 2 onto the 1 and get another 1 and put another 1 on the 1. So we've got 3 altogether.
Ah.
Okay, so this would be quite good for encouraging children to work systematically and trying to figure out all the different combinations. And if you hadn't put 1 on the 7, but you'd put it on the 6 or the 5, there might have been more combinations. I'm just thinking that if you'd had 1 on the 6, then you could either just have 1 on the 4, or you could have 2 other combinations, which are 1 and 3 and 2 and 2, or you could have had, yes, I could see this leading to interesting discussions and work from students trying to come up with convincing arguments that they found all the different combinations.
Great, yeah, absolutely. So we've got 2 tasks in our current feature that make use of this particular interactivity. This one, which is called number balance, and then another one, which we won't look at in detail, but it's called Are You Well Balanced? They use the same interactivity, but they just ask slightly different kinds of questions. So this one focuses more on, as I can see the conversations that are happening in the chat, most people, I saw a couple of people saying that this could be a focus on number bonds, and the particular questions that we've asked have done exactly that. Focused on number bonds, and also, as you've said, Charlie, to think about how can we work systematically to find all solutions. The Are You Well Balanced task focuses a little bit more on, I guess, multiplication as repeated addition. So when you when you demonstrated, Charlie, that we could balance 10 with 2 5s, that becomes more of a focus in our other task. I wonder, Charlie, is there anything that you'd like to ask in particular? I wonder whether it could be a good opportunity to leave everybody to have a little look. This number balance task is nrich.maths.org/4725. So, Charlie, would you like to say something?
Well, I don't know. Are we going to set them a challenge? If you put a weight on the 7 on the left-hand side,
yeah,
how many different combinations can people find on the right-hand side?
Lovely.
I've got no idea what the answer is, so I'm going to work on it on paper.
Let's work on it together. So we've got 7 on the left-hand side. Have a little play. How many different combinations can you have by putting weights on the right-hand side of the interactivity to make it balance?
And you're allowed to have as few as just 1 weight on the right, and as many as 7. So you could have just 1 on the 7, or you could have 7 ones, and anything in between. And the question is, how many different combinations could people find? Goodness, this might be a bit difficult. Okay. Maybe we should have chosen 6. This is obviously too spontaneous for
for a Tuesday afternoon. Have a little go. Let's give you a few minutes to play with that. Somebody's already commented lots. I like that.
Acceptable solution.
We'll leave you to have a little think about that. Alternatively, if you have got some questions that you think you would like to pose to your children to work on, then do share those with us as well. But we'll let you think for a few minutes.
I'm assuming, Liz, that in this, a combination that says 5, 2 is the same as 2, 5, because it just means one weight on the 2 and one weight on the 5.
I would assume so too, Charlie. But and I think a couple of people have asked about that in the chat. However, I think it's one of those instances which we often talk about during NRICH sessions. Is it can be valuable, I think, not to make that explicit right at the beginning of the task and let the question come up and let the children ask the question, and then as a class or as a group, you can decide together. I think in this context, you're absolutely right. It makes sense for 5 and 2 to be the same as a 2 and a 5. Yeah, totally agree.
I can just give a little bit of feedback to one person.
Please do.
Called Catherine Will.
Yes.
I think she's missing one combination.
Ooh, I saw Catherine's post. So Catherine Will. I appreciate there are a few Catherines. I thought that she'd used an interesting system in coming up with her solution. Look, she's puzzled now, Charlie. She's puzzled. Thank you all for participating. And as Charlie said, this was a totally off the cuff particular challenge. A lot of people are saying 15, Charlie. What are your thoughts on that?
That is what I've got.
That's what you've got too. I wondered whether 15 might be the correct solution. What we often do when we work with children, which unfortunately, of course, we're not able to do face-to-face at the moment at all, but a really nice way of encouraging a system we've found is if you ask children to record one answer on a separate piece of paper. Now, what you could do is ask them to do this as individuals, or ask one child in the class to record a solution, and then everybody come to the front. You can have a range of individual solutions on display at the front, held up by children, for example, and you encourage the class to look for patterns in the solutions that they see, and then perhaps rearrange the children in a particular order. So to impose some sort of order on the solutions. And in doing that, what you often find is that children themselves will notice a solution that is missing because they've seen a pattern, they've ordered to put the solutions that have been offered in that, to make use of that pattern, and then suddenly it's obvious what is missing. It's a strategy that we've used quite frequently to good effect. Catherine is responding now.
It's interesting to look at. I don't know whether everybody wants to scroll up to see Catherine's list there.
Yeah, well, I noted down the beginning of it. So if I just talk about, I could say, so Catherine started off and I think she wrote to start with 7, and then a comma, 6, 1, and then a comma, 5, 2, and then 5, 1, 1, and then 4, 3.
And it almost feels like she started with a single weight and then 2 weights, and then started with 3 weights, and then almost like, oh, wait a minute, I forgot there was another 2 weights one. But possibly that didn't go on. But it definitely feels very systematic in terms of using few weights to start with and slowly
building up.
Growing.
Yeah.
And I can see from 5, 1, 1 why you might then go on to 4, 2, 1. And then 4, 1, 1, 1. Yes.
Yeah.
But I think that's your point, because you can imagine on the board sticking solutions which just use 2 weights, and solutions which just use 3 weights, and solutions which use 4 weights, and solutions which use 5 weights on different columns, and then by rearranging them, you can see how you can get from one to the other and see any gaps.
Exactly. Okay, so we hope we've given you a little flavour of this task. I mean, we've gone much beyond what you were very likely to explore with 5 to 7 year olds, but it gives you the kind of the scope. Anything is possible, and I think we'd like to encourage that. Although we in our tasks have asked specific questions and encouraged particular avenues for exploration, you of course will think of lots of other questions you could offer your children, and so much the better. That's partly what we would love to happen when you use an NRICH task and NRICH interactivity, for it to prompt more mathematical thinking, is exactly what they're there for. I think
we have time for one more problem.
Yeah, let's have one more problem. Shall we go back to the primary teacher homepage and the feature? And I'm going to scroll right to the end of the feature this time, and show you this task. It's called True or False. This is for Key Stage 2 and 7 to 11 year olds, roughly speaking. Now, Charlie, I'm gonna sort of put you in the deep end, if you like. I'm going to show you some number sentences while Charlie's having a think. Obviously, those of you at home or school can have a think too. Charlie, I'd like you to have a think about whether each of these number sentences is true or false. And ideally, try not to do any written calculation. Try to think of perhaps what could we call it, like an elegant or efficient way of telling, okay? Here we go then. I'll just scroll down a bit so you can see them. Hopefully you can see number sentences which we've labelled from A to L. Okay, and do I know how many are true and how many are false? I'm not giving you that information, I'm afraid, no. Okay. Well, I'm going to go for the low-hanging fruit to start with. I think C must be true because I've got 19 and 15 on one side and 19 and 15 on the other side. And the order in which I write these things doesn't matter. So I'm pretty sure, so that I think is correct. And the one after is right. And I suspect, and it's quite nice that that's been written. Often students only come across equal signs in terms when there's an operation, and just to be able to have it there as a statement seems good. Yes, absolutely. One of the reasons we wrote this task, Charlie, was for you as teachers to really unpick your learners' understanding of the equal sign, and you're spot on, Charlie. Yeah. Now G looks interesting. Oh yeah. On the right hand side, you've got two consecutive numbers. You were asking for elegant or efficient solutions. On the right hand side of G, you've got consecutive numbers. And I happen to know that whenever you add two consecutive numbers, because you're adding an odd to an even number, you always end up with an odd solution. So I'm going to save myself the trouble of adding the 16 and 17 and say that the answer cannot be 34. You'd have to have either two even numbers to get 34 or two odd numbers. So I'm going to be lazy, not add the numbers, but say that's false. But that's great, and I like the way you refer to yourself as lazy. It's interesting, isn't it? I think you know, we're trying to encourage children, we're trying to develop young mathematicians in the classroom. And although you say lazy in a sort of a self-deprecating way, actually another way of looking at it is efficient, isn't it? And if you can answer a question and reason through it without having to do lots of calculation, brilliant. Yeah. Well, and I think I can also be efficient with H. Okay. Because if I look on the left-hand side, 19 is 2 less than 21. Mm-hmm. I'm comparing the first number on the left with the first number on the right. Yep. 19 is 2 smaller than 21. Yep. But then the second number on the left is 2 greater than the second number on the right. So it's almost like if you take 2 from the 15 and add it to the 19, you must get the same total. So
again, I'm going to be lazy and not add the 19 and the 15. I'm not going to add the 21 and 13. I can tell that they're going to be the same.
Could I just interject there, Charlie? Yeah, that's fantastic reasoning. And I think it's interesting. You're obviously extremely comfortable with having multiple's the wrong word, lots of numbers on either side of the equal sign, where I think some children perhaps have a misconception that an equal sign follows one number. It's a calculate and I put one number on the right hand side of an equal sign. And so part of the reason for including some calculations like that, some number sentences like that, to encourage you teachers to unpick that and address it with children, that actually know the equal sign is about a comparison. It's the relationship between each side. Sometimes this particular task was inspired by a chapter in a book which is referenced in the teacher's resources, and the authors of the book, one of them is Thomas Carpenter. They suggest actually that the way that you read aloud a number sentence can be quite important. So to read out loud something like 19 plus 15 is the same amount as 21 plus 13, just to really reinforce that you're comparing each side.
And I imagine that the earlier interactivity we saw with the balance and the weights does introduce children to that possibility, and especially the way that you had it when we put the 7 on the left, and then we had 10 on the left. So it wasn't the normal way where you put the solution on the right of the equal sign.
Yeah.
So having that flexibility, and if the children have had the experience of working with that balance interactivity, they may find this more accessible and more natural.
Mm-hmm. Yeah, good point.
Charlie, I think I could do I have time to do a couple more?
Go on, do one more and then we can introduce the second set of numbers.
Yes, I think I can do I in an efficient way. I think the two numbers on the right are each one more than the numbers on the left. So 20 is one more than 19, 16 is one more than 15. So the right-hand side must be heavier than the left-hand side. And I can say the same thing about J, where the two numbers on the right are bigger than the numbers on the left. And K is definitely bigger on the right than on the left, because you've got 15 on both and then a ridiculous amount more on the right. But I've managed to avoid doing A, which I thought looked very unfriendly. I think what I would do is I would take one away from the 15 and add it onto the 19. And so I would get 20 and 14, and 20 at 14 then does give 34. And so that would be an easier way of, and I think again, the balancing activity you showed us earlier might be good preparation for that kind of manipulation and playfulness. Right. But anyway, I'm going to be quiet because I know you've got something to give to all the teachers.
I wonder whether you'd like, those of you, I keep saying working at home, I appreciate some of you might actually be in a school. Those of you participating, you might like to have a look at this second set of number sentences here. I wonder whether you could pick out one or two that you think you could solve in a particularly elegant fashion and post on the chat for us. Let's just have a couple of minutes to have a look.
And you mean post in your chat what strategy you would use to decide? Please. And again, there's some that are true and some which are false. Is that right?
That's right. That's right. Sorry. Thank you, Charlie. Yeah, it is difficult not to calculate. I agree. Those of you.
Not if you're as lazy as me.
Anyway, we'll leave you for a couple of minutes to have a look. Thank you very much for your thoughts on the chat. It's a good. I'm glad you're enjoying the mental workout. Some of you at this time on a Tuesday afternoon. So we've had another number of comments. I think F has popped up a few times. That the 581. Some of you have used the phrase cancelling out. Perhaps that's not something that children would use, but if you've got an amount and you take away exactly that amount, of course you're going to have 0. Somebody was commenting on H, that using estimation can lead you very quickly to the idea that that's false. I guess somebody has commented, I wonder what mistake they made there. Yes, a slightly less believable false, isn't it, to some extent?
Could you be doing a standard addition and end up with, you add the 2 and the 9, you get 11, and then the 4 and the 7 and the 6 and the 1 that you carry gives you the 14, and then I don't know, then they did something wrong and got 20 or got.
Yeah. I would encourage you, if you do decide to use this activity with some of your learners, or of course a tweaked example, the great thing about this is that you can create your own calculations that would suit what your children are working on at the moment, and use it as a fluency exercise to in a meaningful way. So I guess this kind of meaningful practice to develop children's fluency. But I'd encourage you, before you offer the particular set of calculations to your class or a group, have a little think about how you predict they might respond. That the authors of the book that I mentioned earlier said that they were surprised that so many of the teachers they worked with were surprised at their children's responses. So yeah, just a little exercise. And as I say, the book is referenced in the teachers' resources, should you wish to look it up.
There's a radio program, Liz, where people try and sneak in untruths or
yes,
truths, I don't know, one or the other.
Yes.
I can imagine getting students to, can you write statements like this and then give them to your neighbour, and can you catch them out? Can they spot what's true and what's false? And they're not allowed to do the whole calculation. Can they, I don't know. It'd be quite fun to get students to see whether they can fool their neighbour into thinking something is true when it isn't, or vice versa.
Yeah, somebody has pointed out it's called the unbelievable truth. Yes.
Thank you.
Yeah, absolutely, Charlie. A great follow-up question would be to encourage perhaps a pair of learners to create some examples for another pair to work on, and yeah, try and catch them out if they could. Charlie, I'm aware of the fact, look, we're rushing towards the end of our time together. I'm just trying to recap. Is there anything we've missed about this current feature that you think would be worth noting? As I said that, I have just thought of something. I'm going to go back to the feature page just to draw your attention to the article that we have here, written by Ems, our director, which draws together the ideas behind the tasks and links you to some research that you could follow up should you wish. We don't always include articles in our features, but this one is particularly relevant and very, very accessible. So do have a read of that if you haven't done already. Charlie, is there anything else you think we ought to mention in terms of that current feature?
No, but just in case teachers don't know, do you want to just point them at the mapping document?
Thank you for the reminder. Let's go back to the primary teacher homepage. I mentioned at the beginning that this purple box on the left is a useful place. If you click the curriculum support link, you'll get a page where we summarise different ways of accessing primary tasks to link with different aspects of the curriculum. But this is the link that you may find most useful. If I click primary curriculum mapping, I get a link to a Google Sheet, which takes all the objectives from the primary curriculum and links in NRICH tasks where applicable. So what you see now, at the bottom here, you can see that we've got various sheets and we're on the number and place value sheet. And if I just scroll down to give you a bit of a flavour, you can see that each objective may have some links to NRICH tasks. So it's a great way of developing children's problem-solving skills at the same time as working on aspects of the curriculum. Thanks, Charlie, for the reminder. What I'm going to do now, is there anything else on the website, Charlie?
No, we're going to want everyone to give us a bit of feedback.
Yeah. I'm going to stop sharing the website, and instead I'm going to share again the PowerPoint that we had at the beginning, which is here. Hopefully you're going to be able to see that. Can you see a PowerPoint slide, Charlie?
Yes.
Great. So although we've come to the end of our session here, if you use Twitter, we'd encourage you to use the hashtag NRICH Live to discuss any of the ideas that we've worked on together this afternoon, and to follow up the conversations. If you're on Twitter and don't already follow NRICH, then do consider following us at NRICH Maths. You may already be signed up for our email newsletter, but if not, we'd really suggest that Twitter and/or an email newsletter is the best way of keeping in touch with what we do and knowing about future events like this. That's where we tend to publicise what we're about to do. That's the link to the primary curriculum map that I mentioned earlier. Finally, not quite finally, but we will put up the recording of this webinar on that page. So enrich.maths.org/enrich-live-jan-2021. And so do feel free, of course, to share that link with your colleagues who weren't able to participate today. The funding that we've got from Trinity College, which I mentioned right at the beginning, is enabling us to try out webinars like these, working with you. And we hope to be able to run webinars in exactly the same way as today, half-termly, to introduce you to the new activities that we publish in our feature each time. We'd love, therefore, to have your feedback. Please do let us know what you think has worked well for you this afternoon and what you think we might have done differently to enable a better experience for you. Claire, I wonder, would you mind popping that link in the chat? That would be fab. Thank you so much.
I'm afraid I wasn't listening because I was replying to something else. Which link was that?
It's the link to the feedback.
Okay, cool. That
would be wonderful. Thank you so much. And you're so honest. I'm sorry to report you when you I'm sure you were replying to something else. So we've come to the end. We hope that what we've done this afternoon has been useful for you and that you've enjoyed participating in the maths. Charlie and I have, I think I can speak for Charlie there. And we hope that we'll see you again at another future event. But do give us your feedback. We'd very much appreciate it. Thank you so much.